All right. Hey guys, so this is going to be the video where I walk through the percent error information that we went over in class. So percent error, as it says here, is the error in percent between the accepted value or the calculated value and the measured value from the experiment or whatever. Essentially what this means is that you are trying to find out how far away from the actual or real value or expected value, how far away you are from that in a measured amount that you're getting. So, for example, say you're trying to do a chemical reaction and you're getting a certain amount of product. You're looking to get 100 grams of product. So you do the reaction and you get your result, and you want to look and see like, well, how close was I to what I actually wanted or needed to get? Like, how close did I get to that? What was my percent error? That's what this is a measure of, right? Accepted value is the amount calculated or given as a known amount that represents the amount expected if everything went 100% perfectly. So that's the either through calculation or given as a known amount. That's the accepted. The measured or experimental value is the amount actually measured in a test or experiment. Okay, then we have the equation. Percent error equals measured minus accepted over accepted times 100. All right, so I'm going to walk through the same two problems that I walked through in class, the first two from the homework. All right. So the first one, Shelby measured the volume of a cylinder and determined it to be 54.5 centimeters cubed. The teacher told her that she was 2.2 centimeters cubed too high in her determination of the volume. What was her percent error? So first, I'm going to organize by putting down my measured and accepted variables. Okay, I know I'm looking for percent error. Measure the volume of a cylinder and determine it to be. So that's my measured value. So that's 54.5 centimeters cubed. Okay. Now, you have to be careful because a lot of times students will get in a groove doing problems or whatever, and they won't even read the problem. They'll just take the numbers and throw them in what they think they are. You have to be careful. You really have to read the word problems, especially in science, because they might not be giving you everything straightforward and just giving you just the numbers you need. They might give you numbers you don't need. They might give you ways to figure out numbers you need, whatever. So, for example, this one, so we need the actual still to do this. It says the teacher told her that she was 2.2 centimeters cubed too high. So that means that the actual was 2.2 centimeters lower than what she got. So in order to figure out what the actual is, we're going to take 54.5 and we're going to subtract the 2.2. All right, this gives us 52.3. So that's going to be our actual amount. So now this isn't going to always be like this, just in this one. So you have to read the problem and figure out what parts you have and how you can get the parts that you need to do the problem. Okay, so our percent error equation is measured minus accepted all over accepted times 100. Okay? So we're going to plug in the parts. Measured minus the accepted all over the accepted times 100. Now, when you throw this into your calculator, you have to be careful. In reality, the way you kind of want to look at this is this in this top part in parentheses. You have to do the subtraction first. So when I throw it in, you can either do that first and then plug that number in, or if you want to do it all together, you can just put parentheses around that. So 54.5 minus 52.3 end parenthesis, then divided by 52.3 times 100. We get this. Okay, now I want you guys to go take your percentages to at least one decimal place. You could go to 2 or whatever. If it's a small percentage like 0.00 something, don't put 0.0 or 0.0. Like, make sure you go out to a few non-zero digits at least. All right, so this one I'm going to do. I'm just going to do 4.21, and it's percent is my label, and that's the answer for the first one. Okay. Now, you have to show work. Right? I said this in class, and I'll say it multiple times. You have to show work. Okay. If I mentioned why in class, if you want to know why, you can ask me later again. But for this, okay, what do you have to show? You have to show at least this part. The numbers in the formula and obviously the answer. Okay. You don't have to rewrite the equation without the numbers in every time. You don't have to write down the variables. I would recommend, at least at the beginning, doing that. Or if word problems or stuff are maybe a little difficult for you, do that. It helps keep you organized. And it helps kind of lay everything out for you. I do that a lot of times, even though I know exactly what I'm doing. Okay. All right. Number 2. There's something on this one that I want to point out to you guys too. So, and I'm going to do, an object has a mass of 35 grams. On Anthony's balance, it weighs 34.85. What is the percent error of his balance? So, still doing percent error. So I went measured and accepted. My measured is the 34.85. The actual is the 35. Okay, so I'm going to put that in the equation. So it's going to be 34.85 minus the 35.0 times 100. Okay, now if I do this, okay, I get this. Negative point, okay, so negative 0. I'm going to go 43%. Okay. Now, on this, if you're thinking of it the way some people think of it, then you can get a negative percent error. The negative just means the measured amount was below what the perfect or actual amount should have been, the accepted amount. The negative just means it's below. Okay. Now, some people who think of percent error more mathematically, in terms of the percent error being how close you are to the perfect amount, think of it like you can't have a negative percent error. In other words, the closest you can be to the true amount is 0% wrong or 0% error. You can't have a negative percent error because that means you're less than 0% wrong, which is impossible. So some people, like, some mathematicians and people think of it more that way. So what they would do is they would put absolute values on either side of the excuse me, on either side of the stuff at the top, and all the absolute values do is it just makes your answer positive. Okay, so this would be the same number, it would just be 0.43 be positive instead of negative. Okay, now I don't care which one you do. I will tell you this, the only time I will mark something wrong with that is if you put a negative on something that shouldn't be. So for example, if you put a negative on the top one, I would take some points off for that. Okay, now if you just want to play it safe, make everything positive. Because if it's supposed to be negative and you did positive, I'm just going to assume that you're doing this type of thing. Okay, so if you want to play it safe, make them all positive. I don't care if you have negatives on the ones that should be negative. So that's up to you. All right. Okay, that's the end of the percent error one.